So this video is integrated to chapter 11, D-Day number 2. So on this first one here, I'm going to add in some of the values. We have AE is 5. Okay, so this right here is 5. I know that AD all the way across that from here to here is 20. So that means that this portion is going to be 15. Now going the other direction, for the other one, I know that BE is 14. So that's going to be 14. And I want to find the length of EC, which is this right here. And I'll call that X. So what I know is I am going to multiply the product of these two segments is equal to the product of these two segments. So I'm going to go 5 times 15 is equal to 14 times X. So 15 times 5, I end up having 75. And then I'm going to divide both sides by 14. And so I get 75 over 14 for my X, or 75 divided by 14 is 5.357. So about 5.36. I would just leave it, since you have kind of not a nice fraction not a nice decimal as a fraction. On number 2, on this one, we're trying to find the length of CD. Okay, or we know the length of CD, sorry. The length of CD is 10. Now, if that is 10, since that is the radius, this also has to be 10. We know that that is 3. I'm just going to color over it. And we want to find the length AB, but in order to find that, I'm going to use Pythagorean to find this AE. So I'm going to have a right triangle. I'm going to call this X. I don't know what that is. This is going to be 3. This is going to be 10. And I'm going to be doing Pythagorean. So I'm going to have basically 100 minus 9 is going to equal X squared. So my X is going to equal the square root of 91. Okay, and I'm just going to keep it like that. And then what is true, since this line segment is meeting this chord in a perpendicular manner, we saw that when that happens, this ends up being bisected. So this AE is going to be the same as EB. So then what I'm going to do is double that answer. There you go. On number 3. EG is a diameter. Okay, so we know that that's the diameter. This right here, O, is our center. We know that FG, the arc measure of FG is 52. And the arc measure of EH is 64. We want to find a couple of things. We want to find angle, and I'm going to do this in a highlight. We want to find angle E. So angle E is this. And you see angle E actually forms that inscribed angle of 52. So that means I am going to take that the measure for that intercepted arc, 52, and divide it by 2, which is going to give us 26. So this is going to be 26 degrees. Then what I'm going to do for the other one is I want to find GPF. So GPF, now that is formed by two chords, EG, which actually is a diameter, and FH here, intersecting inside the chord. And so the arcs that are formed, okay, 64 and 52, if you average those, add them together, divide by 2, you'll get this angle here, GPF. So I am going to take, for this, let me just move this. I'm going to be taking 64 plus 52. I'm going to divide it by 2, and that's going to give me my answer. So when I'm doing this, let me move this up here. Okay, 64 plus 52 divided by 2, I end up with 58. So this is going to be 58 degrees. Okay, on number 4, we have a system of equations that both of them are y equal. So I'm going to use equal values. So I'm going to take 2x squared plus x minus 3 and set it equal to negative x plus 8. I am going to add x to both sides. So I'm going to do the 2x. I'm going to minus 8 from both sides. So I get a negative 11 is equal to 0. I'm just going to check to see if it's factorable. Okay. So if it's factorable, if I take this 2 times negative 11, I get a negative 22x squared. And I want to see if I can get this 2x. 2x. Now, things that multiply to 22, 1 and 22, that's not going to help. 2 and 11, that's not going to help. So this is not going to be factorable. So I'm going to use quadratic formula. So x is equal to negative b, so negative 2, plus or minus the square root of b squared, which is 4, minus 4 times my a, which is 2, and my c, which is negative 11, all over 2 times my a, which is 2. So I'm going to have a negative 2 plus or minus the square root of, and let me put that into my calculator. So 4 minus 4 times 2 times a negative 11, I get a 92 over 4. Let me do that math. So I am going to take negative 2. Make this a little. Okay. Take negative 2 plus the square root of 92 divided by 4. And one answer is going to be x equal 1 point, let's say 90. And I'm going to take the same thing, but change this to a minus. And my other x is going to be a negative 2.90. I'm going to be putting him into one of the equations. This equation is the easiest one for me to put in. So one answer is going to be 1.9 comma. And when I go negative 1.9 plus 8, I get a 6.1. And when I take a negative 2.9, that's a positive 2.9. So for that one, a 2.9 plus 8 is a 10.9. Those are going to be my 2 points of intersection. Okay. On number 5, we have a regular polygon that has external angles equal to 15. If 15 degrees, if each side of the regular polygon has a length of 16. Okay, so first off, I'm going to take 360 degrees, which is the sum of all exterior angles, and divide it by 15 degrees to see how many that is. So 360 divided by 15 gives me 24 sides. Okay. So if there are 24 sides, and each side has a length of 16, what is the length of the radius? So I am going to have a triangle. This central angle is going to be 15 degrees because I would just be doing the opposite math. I'd be taking 360 divided by 24 and I would get 15. I know that this is a 16 and I'm trying to find this. That's what I want to find. Okay. So when I'm doing this, I am going to have a right triangle. This is going to be an 8. Whoops. This is going to be an 8 from here to here. I want to find this length. Let's just say I call it X. And that angle, which was 15, is now going to be 7.5 degrees. So I am going to do sine. So I'm going to have sine of 7.5 equals opposite over hypotenuse. When I work that out, it is going to be X is equal to 8 divided by sine of 7.5, making sure my calculator's in degrees. So 8 divided by sine of 7.5, I end up with that value being a 61.29. That's what the radius is. Okay, on number 6, what is the total surface area of this prism? So to find the total surface area, first thing I'm going to do is find the area of this, which is the base. And in order to find the area of the base, this is a right triangle. This is going to be a 3, 4, 5 right triangle. So to find that area, I am going to take my base times my height divided by 2, which is going to be 6. So this is going to be 6. Now I have that 6 twice, here and here. Then I have these rectangles. Now when I'm doing the rectangles, I am going to have 5 by 8, which is that one. 4 by 8, which is that one. And 3 by 8, which is this one. So I can find each of those separately, or just take the perimeter, 3 plus 4 plus 5, and times that by 8. Well, that's going to be basically 12 times 8. So I'm going to have 12 plus 12 times 8. So 12 plus 12 times 8, which gives me 108 centimeters squared. Now for the volume, I am going to take that 6, which is the base area, times it by the height, which is 8, and I'm going to get 48 centimeters cubed. On the next one, we want to find the volume for this. So when we're trying to find the volume for this right here is 20 by 15. So if I want to find the area of that, 15 times 20 gives me 300. So this base is 300. Now I need to find the height. Now to find the height, I am going to take this down to the center. I'm going to draw it out to that 24. And so for this, if I'm trying to find that this is 20, this is 15, I basically want to find the diagonal, and the diagonal is going to be Pythagorean. So I'm going to take 20 squared plus 15 squared. That is 625. So this is actually going to be a 25. Now that means that half of that is going to be a 12.5. So this is going to be a 12.5. So right now I have this triangle. I want to find that height. Okay. I know that I have a 12.5 here. And then this 24, I know. And so I'm going to do Pythagorean. So I'm going to go 24 squared minus 12.5 squared. And I'm going to get a 4.1975. So this is going to be the square root of 419.75. Okay. So I am going to take that base area, which was 300. I am going to times that by the height, which is the square root of 419.75. That would be it as a prism. I don't have the whole prism, so I divide it by 3. So I am going to take 300 times the square root of 419.75. And I'm going to divide that by 3. And I get 2048.78 as my answer. So on number 8, the surface area of the prism is 240 square centimeters. Its volume is 300 cubic centimeters, and it's reduced so that it's 1/2 as long. So I want to think R squared, R cubed. Now, if I'm making all my sides 1/2 as big, that's going to be my scale factor. My surface area is going to be 1/2 squared, which is 1/4. My volume ratio is going to be 1/2 cubed, which is 1/8. So when I'm trying to figure out the surface area, I'm going to start with it being 240. I'm going to times it by 1/4, and I'm going to get 60 square centimeters. I'm going to take my volume, which is 300. I'm going to times it by 1/8. And so when I take 300 times 1/8, I end up getting 75 over 2. Um, 75 over 2, which is 37.5 cubic centimeters. On number 9, when I'm dealing with this figure, let's see. I know the edges are 8. Okay, so let's say from here to here, I know is 8. I know that the lateral edges are 24. So this right here in orange is 24. We want to find AG. So AG is from here to here. So what happens is I have a right triangle. And here, I'm going to actually make this blue because I have just that portion. Okay, so this is my A, this is my E, this is my G. So I know that G to E is 4. It's going to be half of DE. I know that this is 24, and I need to find my teal. So I'm going to take 24 squared minus 4 squared, and I get 560. So it is going to be the square root of 560. And when I do that math, and so I'm just seeing if there's any squares in this. Okay, well, 4 goes into it. So let's see if 16 goes into it, and it does 35 times. So that square root of 540, I could really clean up because 16 times 35, so 4 root 35 is a cleaned up version of it. So that's my answer, 4 root 35 centimeters. Now the next one, they want AF. Okay, AF is going to be right here. And I'm going to draw that from F to E. Now I'm drawing it in the same pink as I had the base, because this is an equilateral triangle because it's a hexagon. So that is 8 on every portion of that triangle that I just drew. So I'm going to have a new right triangle with an 8 here, trying to find this, and I'm going to use the 24 again. And this is A, F, E. So when I do that, I'm going to have 24 squared minus 8 squared, which gives me 512. So that's going to be the square root of 512. Let's see, divided by 4, divided by 4 again. Okay, so it was 512. I can divide it by, just divide it by 30, sorry, by 64. And I can divide it by 4 again. So 64 times 4 is 256. So actually, this 512 divided by 256 will give me 2. So the square root of 256 is a 16. So really, I can write this cleaned up as a 16, which is the square root of 256 root 2 centimeters. Okay, so now the next part, we want to find the total surface area. So if I'm going to do the bottom, and let me just get a hexagon. Okay. So in that hexagon, we know that from our center out, okay, we know that this is 8. We know that these are each 8. Now, this is an equilateral triangle, which means that if I split this, this is going to be 4, this is 8, this is going to be 4 root 3 because it's a 30, 60, 90 when I split my equilateral. So what that means for my, sorry, just going to move this. So what that means for my area of this hexagon is that I'm going to be having 8, which is the base, times 4 root 3 divided by 2. That's one of these triangles. I have 6 of them to make up my hexagon. So if I clean that up, 6 times 8 times 4 divided by 2, I get 96 root 3 for the area of that hexagon. Okay, so now my sides, each of the sides I know that this is 8. This right here, from here to here, we found that was 4 root 35. So what I'm going to do is to find the area of that, I am going to take my base, which is 8, times my height, which is 4 root 35, divide it by 2, and I have 6 of these. And again, that was a root 35. Okay, so 6 times 8 times 4 divided by 2 is 96. So this is going to be 96 root 35 is the sum of all 6 of these. Okay. So now what I'm going to do is I'm going to add these together. I'm going to just use the space over here. So my surface area is 96 root 3 plus 96 root 35 centimeters squared. Now for my volume, I'm going to take that denominator, the base, which is 96 root 3. I'm going to times it by the height, and that height is the blue, 16 root 2. And I only have a third of it, so I divide it by 3. So I'm going to take 96 times 16 divided by 3, and I get 512. And then root 3 times root 2 is, that's a root. Yeah, root 3 times root 2 is a root 6 centimeters cubed. And that's your volume. This one up here was our surface area. On number 10, we're going to be thinking R squared, R cubed, has a volume of 240. Let's actually not for this one because we're not enlarging it, are we? Okay. So we have a cylinder that has a volume of 240 cubic centimeters. The height of the cylinder is 4 centimeters. So to find the volume of a cylinder, we take the volume of the cylinder. It is equal to the base area times the height, which is 4. So I'm going to end up with 60 is equal to the base area. And so this is 60 centimeters squared. Then I'm going to take that 60 centimeters squared, which is the area, and that's equal to pi r squared. So I'm going to take 60 divided by pi, and then I'm going to square root that to get r. So 60 divided by pi, and then I'm going to square root that. I end up with my radius being 4.37. Okay, on number 11, we have a couple of graphs here. So this first graph is a parabola. It has a vertex right here at -1, 5. This graph is if I want to look for my A, if I go over 1, I went down 1. So that means my A is a -1. So just for that portion, that would be y equal negative quantity x plus 1 squared plus 5. Okay. Now I'll deal with the portion I have here in a second. This right here is a line that starts at 1, 2 with a slope of up, let's see, 2 over 1, 2, 3. So a slope of 2/3. So this is going to be y is equal to 2/3 times the quantity x minus 1 plus 2. Now for this, I don't have the whole entire either one of them. So I'm going to say f of x is equal to, and for my parabola, I have negative x plus 1 squared plus 5, and pretend it has arrows at the ends of this, just kind of got cut off. And this is going to be x is, and in this case, that point where the two graphs meet is closed. So I'm going to count it in one or the other. So let's say I count it with this one, less than or equal to 1. Then the other equation is going to be 2/3 times the quantity x minus 1 plus 2, and that's going to be x is greater than 1. So I can have that count in one graph or the other. I don't have to have a count in both. So I'm counting that one here. Since I get the same value in both situations, count it in one or the other. Okay, on number 12. So when we have a point of tangency, a radius that goes to that point of tangency is going to form a right angle with that tangent. Now we know that ON is 8. Well, this is also 8 because it is the radius. I know that NP is 5. And I want to find QP. So don't know this, just going to call it X. Going out this way, I know that this is 8. And then going this way, this is also 8. And then the rest of that to here is 5. So I have a right triangle. I am going to be working out 13 squared minus 8 squared. I get 105. So x is going to equal the square root of 105. Let's see, if I divide it by 5, I get a 21. 5, 21. That's a 3 and a 7. Can't simplify that anymore. That's going to be our answer.